The black ribbon that connects every city, every neighborhood, every story of our lives. It's under your car tires, beneath skyscrapers, stretching across runways where jets roar into the sky. Yet most of us have never stopped to wonder, what is this material we take for granted, and how does it come to life? Behind every perfectly paved road lies an invisible world of heat, precision, and power. A journey that begins in quarries and oil refineries and ends as a seamless surface, capable of carrying the weight of nations. Asphalt isn't just a material. It's an engineering masterpiece that has shaped the modern world. But its creation is far from simple. It demands towering machines, roaring furnaces, chemical mastery, and split-second timing. Mistaken mixing, heating, or compaction can turn a highway into a hazard. Today, we're peeling back the layers of this unsung hero of infrastructure, from crude oil distillation to aggregate blasting, from giant mixing drums to laser-guided pavers. We'll trace every step that transforms raw earth into the asphalt roads that define civilization. So buckle up. What you're about to see will forever change how you look at the ground beneath your feet. History and origins. Asphalt's story is far older than highways, cars, or even cities. For thousands of years, humanity has relied on this black, tar-like material, long before modern industry perfected it. In ancient Mesopotamia, natural bitumen seeped up from the Earth's crust, thick and sticky, and was used to waterproof boats, line canals, and glue bricks together. The Babylonians built roads paved with bitumen, and ancient Egyptians used it in the embalming of their pharaohs. Later, the Romans, masters of engineering, mixed crushed stones with natural asphalt to create roads so durable that many survive today. The word asphalt originates from the Greek asphaltos, meaning secure, a fitting name for a material that symbolized permanence. Its earliest forms were entirely natural, bubbling to the surface from tar pits or extracted from exposed deposits. For centuries, it was considered a rare and valuable resource, limited to regions where it could be harvested by hand. Everything changed with the Industrial Revolution and the rise of oil refining. Engineers discovered that asphalt could be produced consistently by distilling crude oil, separating lighter fuels like gasoline from heavier components, leaving behind a thick, black binder, bitumen. This breakthrough transformed asphalt from a rare commodity into a mass-producible material. Suddenly, roads could be paved at scale, fueling the explosion of railroads, highways, and eventually automobiles. Modern asphalt is no longer just a natural gift. It is an engineered product. Scientists carefully design mixtures of stone, sand, and bitumen to handle specific climates, heavy truck traffic, or even jet landings. Today, asphalt is the most widely used paving material on Earth, covering over 90% of paved roads in countries like the United States. Its evolution from ancient tar pits to precision-engineered highways is a story of human innovation. Asphalt's history is a testament to the way civilizations harness natural resources, refine them, and scale them to meet the demands of a growing world. But to truly appreciate this modern marvel, we have to look deeper, down into quarries, oil refineries, and the massive machinery that makes it possible. Raw material extraction. Asphalt begins with two raw ingredients: bitumen, the binder, and aggregate, the stones and sand that give roads their strength. Though they'll soon be combined into a smooth black surface, these materials start their journey in two very different places. Bitumen comes from deep within oil refineries. Crude oil is pumped into towering steel distillation columns, where intense heat separates it into layers based on weight. The lightest elements rise to become gasoline and jet fuel, while at the very bottom, a dense tar-like liquid remains. bitumen. It is thick, black, and so heavy it refuses to vaporize even at temperatures over 700 degrees. Engineers carefully treat and test this binder, adjusting its viscosity and adding polymers to ensure it won't crack in the cold or soften in the summer. Stored in massive heated tanks, it waits for its role as asphalt's essential glue. While bitumen is engineered in a refinery, aggregate is torn directly from the earth. In quarries, crews drill precise patterns of holes into solid rock, walls, and load them with explosives. A single controlled blast sends thousands of tons of stone crashing down in thunderous waves of dust. Bulldozers and excavators quickly move in, loading boulders onto colossal dump trucks. From there, the rock is crushed in powerful jaw crushers, reducing massive chunks to smaller pieces. The material is sorted through vibrating screens, separating stones by size, large pieces for strength, mid-sized for stability, and fine sand to fill every gap in the mix. Even moisture levels are tested, because too much water can ruin a batch before it's even mixed. By the time this stage is complete, bitumen is waiting in insulated silos, and aggregate is neatly stockpiled in towering mounds, sorted for precision. What was once crude oil and raw rock is now carefully engineered material, ready for transformation. The scale is enormous. A single asphalt project may require hundreds of truckloads of aggregate and thousands of gallons of bitumen. With the raw materials prepared, the next step is where asphalt comes to life. The mixing plants, where heat, motion, and engineering merge to create the black surface that carries the weight of the world. Asphalt mixing plant process. The asphalt mixing plant is the beating heart of road construction, where cold stone and molten bitumen merge to form the smooth black material that shapes cities. Here, towering steel silos, conveyor belts, and massive drums work together in a carefully timed ballet. Every second, every degree of heat is controlled to perfection, because asphalt has no room for error. The journey begins as loaders scoop aggregate from massive stockpiles and dump it into vibrating feeders. These feeders send carefully measured amounts of stone onto fast-moving conveyor belts, which carry the material to massive rotating dryers. Inside these giant steel cylinders, flames roar like jet engines, blasting hot air over the tumbling stones. Temperatures soar above 300 degrees, evaporating every trace of moisture. Without this step, the mix would fail, trapping steam and weakening the road structure. Once dry, the heated stones ride bucket elevators up to hot storage bins, where they're separated by size. In a control room perched high above the plant, operators monitor screens filled with numbers, sensors, and alarms. They choose the exact blend of large, medium, and fine aggregate, adjusting recipes to match road design requirements and weather conditions. Meanwhile, bitumen, stored in massive insulated tanks, is kept at a constant temperature, hot and fluid like black lava. Pumps send it through insulated pipes toward the mixing drum, where the magic happens. The aggregate pours into the drum, cascading like a waterfall, and a precise stream of bitumen sprays over it. Inside, giant paddles churn the mixture until every stone is perfectly coated. Depending on the plant, the process may run continuously in a long drum, or in precise batches measured one load at a time. Either way, the result is the same: a dense, uniform asphalt mix ready for the road. The mixture is transferred into insulated silos that keep it steaming hot until trucks arrive. Timing is everything here. Asphalt must be kept at the right temperature, loaded quickly, and sent out for paving before it begins to cool. From this moment forward, the race against time begins, because once asphalt hardens, there is no turning back. Quality control and testing. Every load of asphalt that leaves a mixing plant carries a promise: strength, safety, and longevity. Roads are not just layers of black material. They are carefully engineered structures meant to endure millions of vehicle passes, harsh weather, and decades of wear. That promise starts with rigorous testing, where no detail is too small to measure. At the plant, technicians collect samples from each batch, sealing them in labeled containers and rushing them to an on-site laboratory. Here, engineers simulate years of use in a matter of hours. Machines compress, stretch, and twist the asphalt to measure how it will respond to heavy trucks in the summer heat or freezing winter temperatures. Even the shape of the individual stones within the mix is examined under high-powered microscopes, ensuring they interlock perfectly when compacted. One of the most critical checks is viscosity. Bitumen must remain flexible enough to absorb stress without cracking, yet strong enough to hold its shape under immense weight. A slight deviation in this balance could cause early road failure, rutting, or surface fractures. Moisture content, aggregate gradation, and density are all scrutinized. Quality control teams don't just look for defects, they work to eliminate them before asphalt ever reaches a paving machine. Modern asphalt plants are technological marvels, equipped with real-time sensors that constantly monitor temperature, drum speed, and ingredient flow. Operators sit in control, rooms filled with glowing screens, alarms, and automated data logs. If a reading falls outside the tight tolerances, adjustments are made instantly. Some facilities even use infrared cameras to analyze each truckload before it leaves. Field tests continue at the job site. Crews monitor the asphalt's temperature as it's unloaded, ensuring it stays within the precise range needed for compaction. Samples are taken directly from paving machines to confirm consistency. Every decision is data-driven. Nothing is left to chance. This obsessive attention to quality is why asphalt remains one of the most reliable construction materials in the world. Before drivers ever set foot on a new road, engineers have already pushed it to its limits and ensured it passed every test. Transportation and paving. With every sample tested and approved, the asphalt begins its most critical stage: transport and paving. From this moment, timing becomes everything. Asphalt is only workable within a narrow temperature window, and the countdown starts the second it leaves the silo. Trucks built specifically for this task line up beneath massive silos, their steel beds coated with a release agent to prevent sticking. As the gate opens, steaming asphalt cascades into the trucks, filling the air with the rich scent of hot tar. The load ripples like a black river, its temperature carefully maintained between 275 and 325 degrees. A heavy cover seals the truck bed to trap heat, and the driver sets off, knowing every mile matters. Transport logistics are carefully choreographed. Convoys of trucks run in rotation, ensuring a constant supply of fresh asphalt to the paving site. Routes are planned to avoid traffic or delays, because even a short pause can let the asphalt cool too much, making it impossible to spread evenly. At the construction site, paving machines stand ready. A truck slowly backs up to the paver's hopper, raises its bed, and releases its cargo in a smooth flow. The paver's conveyors pull the mixture forward, feeding rotating augers that spread it across the surface with remarkable precision. Modern pavers are equipped with GPS and laser guidance, ensuring every inch is perfectly graded and level. Immediately behind the paver, rollers move into position. These machines, some weighing over 20 tons, compact the asphalt with incredible force. Each pass presses the mixture tighter, eliminating air pockets and creating a dense surface capable of carrying heavy traffic for decades. Operators watch. Temperature gauges closely. Compaction must be finished before the asphalt cools and hardens. This process is a perfect blend of speed and precision. Crews work in tight coordination, with no room for mistakes. In less than an hour, a raw stretch of ground is transformed into a flawless jet-black road, smooth to the touch and strong enough for thousands of vehicles. By the time traffic rolls across it, few will realize the engineering mastery hidden beneath their tires. From oil fields to quarries, roaring mills to laser-guided pavers, Asphalt's story is one of precision and innovation. What seems like a simple black surface is a carefully engineered structure, layered to carry millions of vehicles, endure heat and frost, and last for decades. Behind every smooth road is the work of engineers, chemists, and crews dedicated to safety and strength. Asphalt is also endlessly recyclable, turning old highways into new ones while saving energy and resources. Next time you drive, remember that surface isn't just pavement, it's a marvel of engineering. Like, share, and subscribe for more hidden science stories.